Okay. For the sake of the recording, I'm just going to start over a little bit. And as a quick summary to those on the recording, what we the unreleased feature is this idea of runghc, where we want to run anything from a full Haskell main module to something like this, where we just have a function that we want the user to write. And we want to just give the user a simple function to write because it gives it makes it especially beginner friendly, and I really believe that in this way Haskell can very much become one of the easiest languages to learn. If we can just focus on something like this, right? If I can make my first function just something very simple like this, where I can work with types and begin to understand them, perhaps my thinking and my life becomes a little bit easier, or at least to start learning Haskell and start kind of proving to myself that I know Haskell. Um, and so we can compile and run this, and it will actually test our code. So if I say here, just 5 to kind of hack the first test, I will get the first test correct, of course. But in this case, I will have it wrong. Right, so combined maybes, nothing, and just 3 should be nothing. And so let's write this really quickly. We got x, we got y, and we're gonna say case x y of case x y of just x underscore and just pardon me y underscore. This is um, just x plus y. If we have just x, nothing, we have just x. If we have nothing and just y, we will only have just y. And if we have nothing and nothing is the only other case, then we will have nothing. Unless, actually, I suppose, well, I guess in this test we said that if we combine nothing, it should be nothing. So, actually, pardon me, this would be nothing, nothing, nothing. Meaning that everything besides the two just cases is nothing. So let me even just quickly do this, fix this up, and we should get nothing. Oh, and that's one thing we need to fix, but that will be coming very soon. Oh, our implementation. Did I click the wrong one? No? Oh, okay. Oh, that's because of that. Okay, there we go. So our code was wrong because we had a parse error in our actual Haskell code. Um, and we can see that now our tests are showing that we are correct. Right? We are showing that our tests are showing that we have successfully understood how to write this function, which I think is pretty cool for like a brand new beginner. But we also have another challenge, which is, I'm a beginner. I'm starting to understand things. It's time to take the training wheels off a bit, and so maybe our code is actually going to look a little bit more like this, where we have a full user module, right? We have a full user module, um, and we have imports, and we actually have a module name, and so we get used to kind of seeing the full picture of what is in a Haskell file. It's still not that much, but it is definitely um, you know uh, definitely maybe a little overwhelming, I guess, for if you are brand new to Haskell. Um, and so we can do this here. That's going to fail because we haven't actually written anything. I'm just going to say undefined just to see that this actually runs. We get undefined. Yeah, standard error is called, or sorry, we see output from standard error because our function failed. Um, and we have a bunch of inputs that we are running our tests with. Anyways, so the, 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 the challenge then becomes how do we build a system that works with all of these different cases, right? So we have, one case where we have a main module, and then like this actually, if you're familiar with Haskell at this point, um, you know that this name does matter, right? If this name is user module, then we can know that our Haskell file is located at name of the module name .hs. Similarly, right? If we see something like um, library dot module one, we know that this translates to library module, or sorry, that's not correct. It translates to library module1.hs, right? And so this module name absolutely does matter, um, and is important for us to think about to make sure that this process actually works properly. So, how do we do this? Well, we started with the simplest case, which was just how do we run, how do we run something like, a first program? This was the easiest thing in the world because, and the reason why is I can show actually pretty easily is just because if we go, um, okay, and then we call a shell and we say runghc main.hs. Oh, I need to get GHC in my environment. runghc main.hs. It is very easy to run this, right? All I need to do is put this script in a file and run it with runghc, and then I have a working script, right? So step aside Python. There's a new scripting language in town with runghc. Um, but yeah. Now, when it comes to something like what we wanted to do, I have a tab in there. Where we wanted to take a single Haskell expression and actually run it, right? Because like this is actually running the code. How do we do this? And there's another thing to this as well. Is like we want to be able to test this. So like there's like this is actually a great Haskell makes testing this a lot simpler for us to think about because this code, like this type signature here, is an agreement, right? It's a very very set in stone contract or agreement between the implementer of the function and the user of the function, right? And so you know uh, I guess then in this context, if you are going through this exercise and you are writing this code, you are writing this contract of like, if you give me a maybe int, I'll give you a maybe int back. Um, and according to some testing value, whatnot. And so this is actually a little bit. This became a little bit redundant, but I'll just talk about it anyways. I wanted to be able to test that the process maybe, that we didn't just change this to something else, right? We didn't just change this to int to int, right? Because although I've the exercise is given a template to work on, there's no restrictions to what we can give back, right? I can just say blah, and it will say, what are you trying to do here, right? And so that's like kind of the challenge that we have, and we want to be able to run any of these inputs, right? And these are complex inputs. We want to be able to test them. We want to be able to check certain things about the function heads. And so we had like quite a few approaches to this. Kyle has been working on this for quite a few months, and so a lot of credit to him for that. Um, and but ultimately, we kind of ran into a bit of a problem, um, which is it really ultimately um, came down to just the version of GHC that we're on, and just kind of what made the most sense. We could have always upgraded to GHC 9, but just with the way that I kind of thought to go about this, the way that I thought about the problem, I said actually there's an easier way for us to do this. And so, anyways, this is the version 1, right? This version 1, more specifically, run Haskell in timed sandbox, or run Haskell in sandbox, which takes the source code and the standard input. Um, this is the kind of V1. So what we're doing is, and actually there's another, this is part of the thinking, as for why it did not make sense to upgrade to GHC 9, because it might even become redundant or especially challenging to use GHC 9. And we also are actually kind of using GHC 9 in a different way. But the kind of challenge that we had to work around is that we are running our process in the bubble wrap executable. And so bubble wrap is a just a command line utility that allows you to create like a virtual file system on the fly, and run a command in it. So it's really nice too, because you can kind of sort of select what you are giving access to, and whether you are giving read or write access to. And so this actually here is a bit of a funny Nix trick. Um, so like we are just getting access to the store already. So runghc has been built previously, but it is in the Nix store, not in the bubble wrap environment. But we can just simply say, I want a read only RO, a read only bind onto the Nix store, and then it is able to find in our path, which we set very explicitly, or I guess we not here at least. I thought I changed that or whatever, but it doesn't really matter. Yeah, so we are able to get access to the GHC in our environment, and so ultimately all we are doing here, right? This is just simply we are just simply saying run GHC from a specific GHC version 9.12. Do I actually have? No, I don't. run from GHC. Uh, oh, okay. Um, maybe if I have GHC in my path, it might be easier if I do this. Okay, well, if I have GHC 9 in my environment, um, then I can pick the particular version of GHC I use to run the expected main file. Um, yeah. So right. So this is all this is doing. It's actually quite simple. It's a bit overwhelming, but simply what we are doing is we are taking some some Haskell source file. Oh, and I moved. Oh, I'm looking at the wrong file now. Sorry. This is the one we should be looking at. Um, and which is ultimately the same as the other one, but um, we are just simply building a very small Haskell project in a bubble wrap environment and then running it through runghc. Um, and what I realized with runghc, and this is actually quite important, is that if we go emacs no window main.hs, um, okay, it was locked. If I want to say import main2, and I go to main2.hs, and I say this is a module main2, where, and then I can still run this pretty easily. If I get Nixon, or if I get GHC in my environment, right? So what's neat, and this is I found this out through kind of the experiment. And again, what I'm trying to do today is I'm trying to walk you guys through like sort of my process of how did I like attack this problem, um, uh, in the hopes that like there's some sort of learning to take away from it, and it's also I think a very cool project. Um, but this is one of the things I experimented was like, will this automatically import um, that other module? And it turns out like as long as I'm doing that, and interestingly enough, if I say aws/main.hs, this is going to fail because I'm not in the right directory. But I realized, right, that if I'm in the same directory as my files, then I'm able to find it. And more interestingly, I thought to myself, well, what if I look at temp slash main 3.hs? Is this even going to work? Like, is this, pardon me, module temp dot main 3, where, great. Um, oh, oh, and I didn't, sorry, my apologies. I did not change main.hs to import temp.main, temp.main.hs, or sorry, temp.main3, and I tried this out, and it was working perfectly. So basically, like what I realized is runghc is actually quite competent, and I figured that out because at first we were trying to use Cabal, but like you know something I could not foresee with this project, and I've heard it. I guess I have heard it in other places. Is that like there's just a lot of like issues with Cabal. Cabal is a bit frustrating to some people, and there have been like just kind of I guess weird bugs that you'll hit from like time to time. They're very like few and far in between. Um, far I forget what the saying is, few and far in between or something like that. But yeah, so but basically what I realized is that if I have the directory structure in a particular way, then I actually am good. Like I can use runghc in that particular folder to run it. And so this I actually still here have source slash main HS, and that's because in this context I'm only running like a singular source file, um, which I needed to expand upon if we're going to be doing testing, right? Um, because with testing we're going to be generating our own modules, and so I now need an actual like folder structure to go about this, and so we took out the like kind of source piece to update. Yeah, we took this out so that we could go about it this way, right? And so like basically what this means then is that the variable I pass here, or the type or variable that I pass here, just needs to be something which tells me how to run runghc on some sort of like file structure, right? Some sort of file or folder structure. And so that's exactly what that is. It's actually quite simple. Let me just duplicate this. And these should be public, I believe. Yep, they're both public. So feel free to go check them out. And we came up with this idea of an executable. And so we came up with this idea of an executable. Um, and it's basically, all this really says, we'll get to what a located module is and all of that. But a located module is, we'll get to that. The executable really just gives us two core pieces of information. What file am I running? And what are the other files that this depends upon, right? So I kind of think like it's kind of like libraries, right? We think of like, oh, I'm depending on this library. I'm depending on Servant, for example, or Snap or whatnot. And but like really like the dependence comes down to a module level, where we are really just like one module, right? Our example here with main.hs, when we are saying an import, like we are depending on those existing, and those working properly or those compiling properly. And so we just kind of have that idea encoded in here, and that that basically means that if we can build something like this executable, regardless of what a located module is, it actually doesn't matter for this context too much. Then we can run. Pardon me. Sorry, we can run something if we have all the dependent modules of that script. Sorry. I don't know if I'm getting sick or something, but anyways, so now like what is a located module? It might be pretty evident based on just what the name of it is. I actually would hope so. Because good names are important. A located module is just essentially a module that knows where it is supposed to be written, right? And so this was an interesting problem. This is actually like So and this is kind of actually has been very true to like the thinking process that I've taken. I started with there's a problem we have. There's all of these different facets of the problem. where we have like anything from a single function we want to run to a full user module to we want to run as main HS. Um, so how do we handle all that? And this located module idea is actually probably where it got the most complex because a located module again is just something that is just a module that knows where it is supposed to be written. But if we go back here, right? So in this case, this is actually an easier case for the located module. But I needed to think about a couple things. So what if because again, this is just a template. You could say, I know my Haskell code, and I actually want to use a particular import, right? So I want to use a particular import. I also want to use the language of overloaded strings, the language extension overloaded strings. And the reason this is particularly challenging, to be clear, is because we just don't have access to GHC9, which has a beautiful library of GHC libparser, which would allow us to get deep access to what this actual file contains. But so let's we have this import data.maybe, let's say, and then we also have module main where. Right, and so someone can write this. Someone could also say, main, or like they could essentially give us whatever they want. And so we now need to think about like kind of two things. What is like runghc gonna do, and what are we gonna do in response to runghc? Because there's a particular challenge that we wanted to avoid, a particular user experience challenge that we wanted to avoid is we didn't it wouldn't be very good, I think, if we have this sort of like we don't want this super virtual environment where there's a lot of things that are specific to ACE and ACE alone. And so we've done our best to kind of minimize that. Like if I, like, just to give a clear example, like if I click compile and run, I would rather you get this error from GHC directly than us saying, hey, we see that you said main. We were expecting something else actually. Can you please change it or whatnot? That would just like that would not be maybe a good learning approach, especially if you are at the point in these exercises where you are becoming a little bit more intermediate, and you want to actually write full modules yourself. You don't want just a simple template with just the function itself. And so yeah, in this case, so like there's kind of like this challenge relates to the located modules because the located modules is basically the that type, right? That type ultimately represents an intersection of what is going on, right? It represents an intersection of what is going on and how the project all links together. And so we basically, the key challenge is that we need to build an executable which is properly linked, so to speak. And so like we're not like what linking usually means is it's a low level compiler step where when, and this is actually something I learned about for a different thing I was doing for ACE. Forget what it was, but I got really deep into the Android updates that needed to happen, and there was a change in the the Linux page size of the executable for the Android executable that we're supposed to ship through the Android Play Store. So I got really deep into linkers then, and basically linkers are really complex, but at the same time, linkers are kind of simple because all they are doing is they are working with this idea of symbols, and basically trying to say, can I find the actual meaning of this symbol, right? So like this concept of like located module, right? I'm showing you guys this located module. You guys are assuming that I'm not full of full of shit. I mean, hopefully not. I could be full of shit. Um, but you guys are assuming that this exists somewhere in my project, probably. Or, if not in my project, in someone else's project. So, um, and that's all the linker is going to do, is going to say, is going to do a lookup of, like, where can I find the actual meaning of this symbol. And so basically what this meant is this kind of became like a first principle um, rule that I needed to follow, that like if we are building an executable, we need to make sure that we are going to build something which can be linked, right? And so we kind of have our own concept of linking, and that relates to the located module. Um, so let me we'll come back to that. We'll talk more about the linking and symbols. Um, but we have this concept of a located module. Um, a located module. So a located module can be either two things. So kind of like as we've talked about, with, like, let's say you give this, right. This input would evaluate to being a located script, or which is one case of our located module. Um, and we'll talk about what a system module is in a second, but a located script is basically just saying, you know, we have a plan for where to write this, right? It's actually just right here. We have a plan for where to write this, and we haven't done any inspection. Right, a script is like we haven't done any inspection of what is in it. We kind of like it was an interesting case to think about because, you know, on the one hand, I could use some logic and some tooling to confirm whether or not your script is correct. Maybe there's a glaring error. You haven't done an implementation. You're going to get a parse error. And in theory, I could do some work through GHC libparser, which I'll bring up because it's actually so cool, and I'm going to share it in the chat. But I think this is just such a cool thing. Or I'll go to last documentation, pick this one. Is this calling runtime Haskell from a compiled program? Yes, ish. So this is maybe a good point to kind of say, like, so what are we actually doing? Right? We talked a lot about, like, the challenges of what we are trying to do. We are trying to build, right? We are basically building a writer program for a executable, right? We are building a meta program of sorts, right? This runghcBWrap-core you can think of as a library to build a Haskell program, and to build a Haskell program properly, right? And so I have a lot of Haskell helper functions to do that. And so right now we're just kind of going through what are the actual types that facilitate that, right? So again, the types as a recap, or not necessarily a recap because I haven't said this exactly, but our types should really help to model the problem, right? And so we were looking at the faces of the problem, um, and we saw a number of challenges that we need to handle, like the variability of user input, which can be everything from just a plain simple user function to a full-on oh, uh, module. Um, and because we don't have the GHC lib parser, it's a little bit challenging to handle this. So um, but ultimately, right? And this is kind of the next thing I thought about. I didn't like to be clear. I did not think about how to make this first. I kind of thought about like this is my goal, is I want to build a located module, something like basically I want to know how to build a representation that contains this text and tells you know, uh, this function where to write the file, right? Because we're going to write these located files to path eventually, and we are going to run them through runghc in the bubble wrap environment. And so that means that we need this idea of a located script more specifically, right? That motivates this concept of of a located. I almost said motivated script. It's a located script. That motivates this concept, and so we can build this idea into this. And if I don't get back to it, someone remind me to explain why this has JSON instances, because that's actually a really cool thing about this. Yeah, we'll come back to that. So that's motivated that, right? So I have a way to represent a script that someone has given me that I'm not editing. I'm just running it as is, and I'm running it at a predefined, like a pre-configured, if you will, place that I need to choose for it to run. Because the other thing is whether or not you give me a full module or not, I still need to write tests to handle this code. Right. So if we run this, let me try this here. So I make my module here. I see main 2, and it's good to get used to this error. It's good to get used to any Haskell error because they're really helpful. This is simply saying it's really small, but this is saying the proper module name is user module, not main 2. And so if I fix this, this will run properly. So yeah, and so the reason this runs properly is because the place that this file must get written to, according to the test at least, or according to the helper function building the test, is that this should get written to user module.hs and run. And we're gonna, by the way, have a testing file called main.hs, which is going to have an import of user module. Right? So, at this point, we are building an executable, which is why I say that. And so, yeah. So I think that motivates that. How do we handle the other case? So what does it look like if we have the other case? This is another thing that kind of threw me for a loop is how to think about this, because really what I originally thought was that we'd have a a representation for like, I don't know, two different types of user modules. But that almost kind of became silly just on the way that I wrote the testing files. And we'll come back to that. But basically, it made more sense to think of, you know, to think of this as something being built. So we are, this is not a valid Haskell module, right? I cannot just run this, at least with runghc, because if I run this with runghc, it's going to be expecting that main exists, right? What even happens here? Oh, I guess that, yeah, right. We're fixing this, but yeah. But so we take this and we need to build this. So what I said is instead, if I detect that the kind of code given looks like this, I am going to wrap this raw text in a idea called expressions. Oh, okay. I guess our do we have Google running here? Let me just do this. But in the meantime, we are looking for expressions. How to find expressions. grep srn expressions. I think it's a new type. So, oh my lord. I mean, there's really not much to show, but ultimately, just what expressions is just a very simple new type that says the text that I have here is just a set of expressions, right? So what expressions means in particular is that I have there is no imports, there is no module name given, there's no language extensions given. It is just a set of expressions, right? And so I literally just I kind of I try to really focus on my types more than usual this time, and I just started with like this expressions idea, and I said, okay, I either have a script or I have an expressions. How do I go from there? And what I did is I came up with this idea. Of where is it? Handle parse the user script. Yeah, I came up with this idea of parse user script. It was a little bit like this is a little bit more into the future of like me problem solving this. I'm kind of giving you guys like the trimmed down, no rabbit holes way that I attack this, or the thinking that I went through for this. This parse user script was actually quite different, and I wonder if I have the old version. Yeah, I mean, I kind of had like I just had a number of very bad versions, but ultimately what I needed to do, the problem, like understanding the problem very well, or trying to take the problem piece by piece, led me to knowing that I exactly need this this function of parse user script. Um, and what I need is I need a way to take user input from scratch, um, and give me either a script or expressions. And I also have other particular cases. We can kind of ignore this conceptually for now. It's not super important, but there's certain cases where we might actually want something slightly different. And so I offer up that ability to anyone using parse user script. Um, so, but ultimately, I guess if both of these are set to true, if both of these are set to false, then it's going to default to giving me back a script instead of expressions. Um, and so, what the way I went about this is I didn't have GHC libparser. I tried just writing my own parsers at first. That proved to be very quickly difficult, just because, you know, I mean, parsing is a great exercise because you think you know what you're doing, right? You'll write something like this, like you'll write a function to parse module main where, and then in actuality, the user is going to give you something like, you know, it's something like this, where it's like it's now like this. It's still conceptually the same thing, um, and we also need to think about this piece or whatever of the parsing. But all the white space and stuff quickly makes it just very difficult to actually properly do. But that's actually why I have my Scrappy library in the way that I do. Um, and so how am I using this here? I I use Scrappy in find module head pieces, and then this function exists is directly from Scrappy. So this is exists is very simple. It takes a parser, um, and if you're not familiar with parsers, please raise your hand, and I can do a more thorough explanation. Um, I will also touch on them a bit, but this takes a parser and checks, does anything parse like this in the provided text. And so basically, we're asking, does main exist, right? Do we find anything? Do we find the string of main IO, um, or um, main equals? And if we do, then we have something that should be run directly. Is why that exists there. But we basically, more importantly, we ask, like, do the module head pieces exist? Um, and if they do, then we are going to return this as a script, um, and not in expressions, right? So we want, if we can, we kind of try to parse it as in expressions, but if that's not going to work, we just reduce it to a script and run it as is, right? We basically say you are like, it's kind of like the how Haskell has like unsafe constructors, right? You'll see something like I think Reflex actually has a good example, unsafe dynamic. You could in theory just build a dynamic yourself. Um, I would feel comfortable with doing this. If you're new to Reflex, I wouldn't do it. I don't even use this myself, but I just know it exists. Um, yeah. So right, that's kind of the idea we're going for there. Is that the user is running their code as unsafe and that it might fail. We are not trying to kind of handhold in that case. Um, Now, so for a module head piece, um, right, we have find module head pieces. This is going to take some text that we're going to scrape, um, and we are going to find, or we're going to return, Scrape is going to return a list of what it found that matches what we're looking for. Yeah. So it's running this module headpiece. And so this module headpiece is a parser which is going to work on, it's going to try and find the string module, it's going to try and find the string where, it's going to try and find the string import, and look for language extensions as well. And this is actually going to get improved upon. Specifically here, there's some clear ways I can improve upon that I will get to, but for now, it ultimately seems to be working pretty well. Yeah. So where am I looking here? So yeah, that's the idea. We are looking for those pieces, and if we find something resembling, a sort of module head, if you will, is kind of I'm calling it, right. We have the expressions of a Haskell script, and then we have the module head, right. And to be clear, right, like that is really the shape of a Haskell module, right. We have the shape of a Haskell module is that we're always going to have a module name. We might have a language extension or other pragmas. We can also have pragmas here, but not necessarily important to me in the context of the runghc stuff. But we have then our imports, which must come next. Import. Actually, I guess this is going to be important. The other pragmas, like we could have, actually, I think that's even still above here. I'd have to check. But anyways, we have our function head where we maybe import something. We're going to import data.text as t. And then everything else here, right? All of this code after our last import is technically a semigroup. And if you're not sure what I mean by a semigroup, and this is a little bit challenging to understand, I will say, or like why is this important? Why do we give a crap about something like a semigroup? And it really comes down to this associative keyword. So binary just means 2. Oh, and they don't. Do they not have the? Oh, okay. Oh, because I'm not in the right. Let me pick a better. Sure. There we go. So it gives us this function signature here. We have an example of putting 2 lists together, and why this is a big deal. It's not really apparent when you first learn it, but it's basically that it's nice to know where associativity exists, right? So associativity just simply means like, if I give you 2 plus 3 and 3 plus 2, are these two things going to be different? And the answer is no, right? 3 plus 2 is always going to be 5, and 2 plus 3 is always going to be 5. More generically, if I give you x plus y, and we know that it gives z, right? And I give you y plus x, whatever they are, we know that they are going to add to z. On the other hand, something which is not associative is the idea of subtraction, right? So we cannot say, that x minus y for sure equals Z. It could. Maybe in I can't think of any examples, but there's probably a case where it might, and it might equal Z in a certain case, but it's not definitively. Right here, we definitively know that we are safe to switch around the order of operations as much as we want, right? Um, and there's actually a specific monoid to represent this, which is just the sum type, or like literally, it's like sum, which is a new type. Um, anyways, so the point that I'm making here is this source code here is monoidal. Right? It doesn't matter. This is not true in every language, right? We could have main here. Let's say, then main equals print 3. There's not a problem if we like have our main before our new type, right? And so everything here is monoidal. The one exception is there are template Haskell expressions, but since we are working with a builder type, this is something that we can kind of control. And so I mean, it would be nice if we could use template Haskell in our test script generations, but it's not strictly necessary for us. And I'll say actually that's one piece we haven't talked a lot about is the idea of test scripts. So let me show an example. Actual like practical example is we're on exercise 5, I think. Oh, why is it not finding that? Go to exercise 5. We're on chapter 6. Chapter 6. Exercise 5. There we go. So we just want to be able to write something like this. So this is where we're actually kind of using the idea of, or like why it's important to note something is monoidal, is because, and I guess here's not actually necessarily the best case. Let me quickly try and find a better one. Actually, I know where a better one is. Chapter 1, maybe? No, wait, I did them in reverse. The first one I did was chapter 7. Chapter 7, there was... from full script. Handle user input signal execute. Okay. This is actually less clear. Anyways, what I'll focus on it. I'll pick an example and make it work. So like the idea is that like I would like to be able to, when writing these test scripts, to be able to combine them, right? So like if I want to test that you have used a very particular type, right? So let's say in this monads example, you are supposed to come up with a new type of x, and it has a string or something. I want to be able to, in my code, build a, a generated test that just comes up with like some sort of gibberish looking thing that just ultimately says that this is the type user module dot x. Right, and I can quickly and easily think of a user, or I guess a generated test like this that is just going to look like this. Um, and yeah, so if I want to build generated tests like this, and I want to be able to combine a million of them together, it's nice to know that the concept of expressions is monoidal. Anyways, so that's a long deviation there, but like basically, now as there's kind of two pieces that there's a lot of people that this library has to think about. One, the user of who's actually writing their own code, and two, the implementer of such tests. And so that's like more where we're going to see this idea of from system module and building a system module. And a system module is kind of something that we can directly construct from an expressions, and we can also add imports to it, and we could add extensions to it, right? So we're going to end up with this data type, which basically this is kind of like getting to the core cool thing, I think, is that like we're just building a representation that can be can be converted to a string directly, right? So I have a function somewhere. I forget what it's called or how exactly I do it. But well, when we call write executable, it's going to call that function, which is going to actually render this system module to being a string, right? And so as long as, even though I'm doing something kind of funky, and that I'm building Haskell code from scratch, like on the fly, and obviously we don't want to be pushing out tons of bugs that can only happen at runtime, which is a key challenge to think about here, is we also want to we want to avoid that happening. And so with this type, we can easily just think about this, and we can easily say, where is it? We can easily take this type, right, and think about whether or not we already have the function written, right? We could easily take this type and see how to turn this into a valid written Haskell module, right? And so if this is expressions only, well, actually there's another piece to it with the location that we will get to, but actually that's a key point is that I'll come back to. If we have expressions, we know how to write just expressions, right? I guess that would kind of look like, that would look like just this, I suppose, with a little bit more. We'd also have the imports up here, right? We'd know to import data.text before we do any expressions, and we would know for our extensions to be up here. So yeah, we would know for our extensions to be up here. But there's another piece that is missing, which is this idea, or the actual module name, right? And so we haven't, this is kind of one of the ideas of this type, is that I wanted to be able to reuse code as many times as possible. And so that is why this system module does not define where it is to be written, right? So I actually I kind of lied. I can't not take a system module, right? I have nowhere that says system module, in file path, and write it to file. Or actually, I could in theory do that. I suppose. Now that I think about it, right? I don't have anything that converts this directly to a rendered text. Um, but what I do have is um, now this generic idea of locate. Um, and locate, I guess you're kind of seeing too. Um, that's not what I'm trying to show though. Oh, I had to move it. No. The locatable class. So um, locatable is a class that works with a data type that can be converted into a located module. And so there's really three cases of that. We have a core user script that is locatable, right? So we haven't done anything to it, and we can locate it. And again, like, so how does that work in this case? Um, and interestingly, like in this case, we want to allow for the user to fail, right? We want to allow for the user to say, oh, like it was actually not in the right location, um, or my module name is incorrect. Um, yeah. The system module we do not want to fail, and expressions we also don't want to be able to fail. Um, right. So and really, like, again, what is this? This is a full user module. This is a module that we created. Like that. Sorry, like that the library created. Um, and this is user input that we were able to convert to expressions. Um, right, and as we just saw, right, we can. It's very trivial to turn expressions, right, from the user input into a system module, right? This concept of something we are building, um, right? Because at that point, well, there's another case to this. Let's say the user, we're trying not to overwhelm the user. They're brand new to Haskell. And we actually, for this problem, we need, like, I don't know, data.text. We need data.int, let's just say. But we don't want to, like, we don't want them to be focusing on that. We want them just to simply be able to focus on one singular function. Well, we can do that, right? If we can parse the user expressions as expressions, then we are able to turn that into a system module where we have things like this function of add imports, right? We can add imports um, to a system module. I don't know if there's more than one case of this. I think this class is a little bit redundant. The only case where the class seems to apply, I believe, is to a system module. So I'm not really sure why I created it, but the idea is, right, that a system module can add in imports, it can add in extensions, right, language extensions, and it can add in expressions. Um, so, yeah. Um, but back to where we were. Um, that's the core of the domain that we are working on. The last kind of piece, right? And as I was talking about a little bit, we want to be able to defer this locatable piece to the last possible second. Um, and so, like, this past segment is just really something that we can easily convert to a module name, as well as to the path, right? So a path segment, it's also just a new type, which just takes some string, right? And we could just say, we'd have something like this, right? We'd have path segment user module, right? And this is going to convert to being, if we were to say to file path, this would be user module.hs, right? And so like the key theme I'm trying to really get across is that by using a strong type system, we can really easily render some complicated thing, right? We are literally rendering a complex Haskell project that we do, we kind of interact with ourselves. We kind of use this as a backbone to write our tests in, and sort of provide that user experience. But yeah, so right, so we can, we've located these things, and now we have a located module, and we're right back to where we started with our executable. Right, our executable just takes a located module that we have called main. Right, we're gonna run that. We're gonna run GHC on that module as y. And then we have all the dependent modules, or the modules that main module is going to import. So ultimately, right, if we have followed the type system to this point, we should not have anything that unexpectedly fails, right? So the only failure that we are allowing through this whole sort of build pipeline is that the user can write their own full script, which can fail, or the user can write something which on import is going to fail. And I'll come back to that. Any questions at this point? Cool.
Nothing for me.
Right on, right on, right on. Nothing in the chat, right?
We went on a bit of a side quest, I think. But I think Zenon asked a follow-up question before.
Oh. Oh. Yes. Yes, it is about commutativity. Yes. Um, he's gone now, but he's absolutely correct. Um, is it possible for the pass program to interface with the runtime system? Could it be used to create application plugins? Um, is it possible for the pass program to interface with the runtime system? How do you mean? Or could could you give a example or?
Sure. I gotta drop soon. I'm not feeling so great, and I gotta walk the dogs. But
Sorry to hear that.
it happens. Anyways, I'm currently in the process of building essentially a plugin system for, I guess, responses to events.
Yep.
And I have been wondering if it's possible to have like a core binary and to extend that binary by having a place that it looks for plugins. And I think that just generally fell into the same. It seems like it might fall into the same category as this, where you have a written script that performs some actions. And I'm wondering if you could use this kind of written script to perform actions within
Yeah.
within the system itself, rather than in a sandbox.
Yeah. So, and I guess the next part will kind of like talk about how we use it as I guess like really um, we're using it as a plugin. We're using the user module as a plugin to our generated executable. So you could do that. What I would say though, yeah, I guess like it really depends on like the use case for like I would try and avoid this way if possible. Like I thought a lot about like Haskell plugins because it's interesting because it like with the more types it can it can make things a little bit more challenging in for plugin systems. Like I know I've worked with like systems before that have like Python script plugins, and they'll actually my day job is basically all a plugin system. It's actually it's not well run. It's not well done, but like it is a huge plugin system, where it's basically Python running a Python script. So you can absolutely do that. I guess and it would if you're calling it as like a forked process, it wouldn't really I guess be a problem because like the challenge then becomes just thinking about like user input. Um, and that's actually the whole challenge is like um, I guess like you know like ideally user input is like as simple as possible. Ideally, they're just giving you a number and a string or whatever, and that's all you need. And that's like in my mind that's a plugin system. But then also too, I can see cases where you'd want to have a function. Like so, I guess if you are at the point of like the data type that you need is a function, like and there's no way to simplify that, then I guess this would be actually a good use of this as a plugin system. Because yeah, you could use it as a plugin, and so that actually leads very well into this next point. So I was trying to find a good example, and I don't know why I didn't just think of this, but this is like Trivial Builders, the Trivial Builders module, and this just does really really simple stuff. Do I have even clearer example? Um, run main. How do I? How did I do these though? I did. Yes. Okay. So I'm gonna need to find that function. So I have this function, or these three functions, or these four functions, I should say, make up the majority of everything in the um, in our code base for all of the testing of given things. And so we can see this in use. Let me find what are we using in this one. I think we're probably using with f. Yeah, with f. So with f, right, just this function here. And with f, to be clear, is a more generic version of runf, right? I could say run main, and that's going to take a user script, right? I could even arguably I could say that this takes a script, not a text, and that might be a little bit more clear documentation. Um, yeah, so this takes a user script and runs it as, or sorry, and builds it as an executable. Um, and really, it's kind of a pure thing. There's not even really a need for this either. This is actually just more for my sake with Ace. Um, but that's going to be factored out. Anyways, so yeah, this just builds a simple executable, which is going to look for main in this provided source code and run that main code. Um, and so what that generated code is going to look like is we're just going to have import main. Let me just actually. We're going to have a I don't know where that code is exactly, but I'm not going to try and look for it. It's a very tiny, tiny, tiny. Oh my gosh, that's why. It's very tiny source code that literally just looks like module main where, we have import user module as user, and actually, this is actually generated from. I have a. Where is it? This get located user module basically builds the import for me of the user module and then applies it to this main, right? So I actually in all of the functions that use runf, there's going to be this line import user module as user, and that's just because I've used the core logic of location. Right? If we have the location of a user module and we have access to that user module representation in our in our function, then it's very easy for us to generate this import. And then we would just simply say main equals user.main. And that would be it. This is the first one I wrote, and I kind of said, well, this is actually really simple. I could actually just make this whatever I want. And so I turn this into, runf. And so I can give an arbitrary name, and it will be, user.f. The key thing being that this must have the type of IO. But also a nice thing about this is that if this fails, then the user gets back the GHC error that the types are mismatched. So that's nice. And I don't have to worry, right? Kind of GHC does my user error handling for me, I suppose. But yeah, that's literally the contents of the generated script. It is super simple for run main. Run main, run f. And then I have, pardon me, with f. Where do I have it here? With f, and so with f is and don't worry too much about what this is or whatever. This is just basically is a data type which just takes the starting code and then also the associated code. This is more just to keep my brain all together for focusing on a particular problem or particular exercise, I should say. But yeah, we have this with f function, and so basically we're going to give the name that we expect for the user to write, and that that's also kind of just self-documenting. And then we have this function called test double list, and so we have this test double list. It takes a function name and provides a script, and so here. We kind of have, like, this is a little bit of magic. Not magic. I should not say magic. But we are using template Haskell, which is going to help us with writing this script. And so where are we using the template Haskell? It is right here. So iString, or I guess right here, and right here, I should say. iString is a function that I have basically just it's from a old library. I made an updated version of the library myself. It's on my GitHub. If you guys want to use it, I think this is pretty. It's actually like one of the most useful libraries I have used because I use it everywhere. But we are using string interpolation to build our quick little script. And so what this is going to say is, like, if fname, right? Fname is ultimately double list. And so this is going to say, let double list equal user.doublelist. And then we're going to go about our code and just write it like any sort of normal Haskell function. And yeah, right. We can see this is just kind of like a arbitrary script that we can write as a test script, right? And so we do have the option to build a system module and build more systematically that way. But I just kind of wanted to get a lot of stuff done. So to be honest, I use ChatGPT to kind of like generate a lot of these tests. As they are quite trivial and there's a lot to do, and so it was just able to generate this code for me. But if I was actually going to do this myself, or maybe if the runghcBWrap-core library was a little bit more mature, because there's still some issues I want to work out with it, that I would build a system module and then work that way. But yeah, so that's how I kind of, I don't know if Zen is still on the call. No, but okay. That's how I kind of use it as a plugin system, right? But I think that's actually a really interesting idea, because that is something I've thought about. Is like, do we have someone off mute? Feel free to jump in at any point. Just interrupt me if anyone has a question. Always. But yeah, like I think the idea of a plugin system is really interesting because I actually saw a post today in the subreddit for programming languages that is like source generation beats compile time meta programming every single time, or like that. They think the better way to do meta programming is through source generation, which this would be source generation. And right here we are generating source. Actually, I guess we're generating source through template Haskell, so it's a bit muddied. But yeah, like this is perhaps a nice way that you could say, maybe I guess really like right, if you guys wanted to use this library, a fun way to do it would be to write a plugin system. Like, hey, if you give me a script of some sort, I am going to run that script for you. I'm going to run that Haskell script for you. And I think it'd be cool to think about because, to be clear, what you do not want to do, is just give them the ability to run anything, right? You'd probably actually want to give them the ability to just run a pure function or something, right? A pure function, and you probably want to run it also in bubble wrap, because there is ways around pure functions if you know what you're doing, right? It's not like if you gave them a pure function only, then they couldn't hack it. They could use unsafe perform IO, right? Which just basically, is this in here? Unsafe perform IO, which basically is the backdoor into the IO monad. So we don't want to rely on it in that way, I suppose. But yeah, I don't know. Very interesting thought to have on that. And so I think that, oh yeah.
On the side note, I think I didn't realize you could use. I don't know why it never really occurred to me. Like I said, I've never really done much with template Haskell beyond using like libraries like persistent. But the fact that you can actually use it for like string interpolation, there's quite a few things I do with Bash scripts, which I really wish I wasn't doing with Bash scripts. But a lot of that comes down to the fact that I want to do some level of string interpolation into what I'm doing. But I'm just seeing there that you could basically do that within this instead and use string interpolation. And then I'm wondering, you've shown in other parts where you're basically invoking nicks from a Haskell program as well, haven't you? So there's a lot of what I'm doing at the moment, which I'm wrapping up in Bash scripts, and I'm just realizing I could wrap this up much more nicely inside of Haskell than what I'm doing right now. So that's something I'm really gonna have to go away and look at, I think.
Yeah, and I'll say too for like the Nix piece because I found that quite interesting. To kind of just mess around with, right? What I did
Mm.
is I just used static which to get Nix shell. I'm not actually doing necessarily much with it, um, but the end goal, which is very far away, um, I think it'd be so cool. Like, just this is more for fun. If like, let's say you take import data.text, pardon me, and I know there's a way through Hoogle. There's a Hoogle command line utility that would allow us to say this data.text is from the text package, and then text is provided by Nix as Haskell packages,
Right.
right? And so I'm like, how cool would that be if we could just build, like, if instead of you know, instead of runghc, we had a Nix shell runghc or something like that. Which takes as input, right, like a list of strings, which are ultimately the packages um, in question.
That would be, yeah. And also, yeah, that would be really nice. And there's a lot of things you could do then with you can actually get it to output the exact way you get it from as well. There's elements of, like, one of the things I've been hearing a lot about from the Node.js world. I know we get around a lot of the issues that things like Node has, but a lot of things have been is that people don't realize that that it's just kind of auto updating, so you don't know what packages are really installed. One thing I found with Nix is you do get the lock file if you use a flake, but sometimes you don't know necessarily what version of something you've got because Cabal finds it, and then, do you know what I mean? Unless you have Cabal output those files, the versions. If you can actually get Nix also to, well, you could use this to output. You could very much know exactly what is being used in any build, and then if there is a problem with any particular version of something, you can search. Just grep the project and say, oh, okay, no, I am using that. Oh crap, I need to think about that.
Right.
Because I think the one thing I find I love I'm not anti-package managers and stuff, but you don't want them to hide that you're using something because you might end up finding out that thing is not secure at
Right.
some level. You know what I mean? So
Right.
yeah.
And
So I think that's been good. That.
it's interesting too, like because I'm not. I thought like I was saying at the start, like I thought I would need Cabal, and then run GHC just did everything I needed, and I'm like okay, but like run GHC could literally just import like this massive tree, right? I could have main imports temp dot main two, where temp dot main two imports, um, x dot y dot z, and it's like okay, like that, like where does what does Cabal exactly do? Yeah, because I thought that was like, I mean, of course Cabal um, make sure other packages are in the environment, but you could also do, like through Nix, you can do GHC with packages, and then that will have access to whatever packages you give it. So it's like
Yeah.
I don't
I
know.
think I think Cabal, when you're using Nix, from what I understand, Cabal is basically only figuring out the versions. Like, it's doing is basically some versioning. So if you want to pin things to particular versions anyway, that's something you might not want Cabal for. But from what I can tell, when I'm thinking about what each bit's doing, because Cabal can be used obviously to do the bit we use a lot of Nix for, which is to actually install things, but we're not really using it in that way. We basically use, but we're effectively generating if you use this version of text with this version of GHC with this version of whatever other, making sure all those versions align as well as possible. Because like most my Cabal files, I don't put a version in, I let Cabal sort that out for me.
Right.
But that's why I'm like, but at the moment I've got that kind of all wrapped up in one thing. I kind of want to output that, so I've always got so I can actually go look at what versions I'm specifically using. because like I said, it kind of hides a lot. So the fact that, but you're saying that you could even get rid of the use of Cabal if you do, but then it's the question of how do you want to sit there and figure out every single version of every single package and how it all interrelates. So I think about I'd almost want to stand like, so maybe this is something to do at another time. Like maybe get rid of Cabal and use something else that just all it does is pin the if you want to use this version of something, it'll probably be GHC, which is going to determine what you're using. But if you say I want to use this version of this with and this and this, can you figure out all my other versions for me, and then print it out? Then you can just surely install it all from Nix, and you don't need Cabal. But then maybe just reinventing Cabal. I think Cabal's got probably a lot of dead weight if you're using Nix. Do you know what I mean? But might not be the biggest issue.
Yeah, yeah, because it's like the one thing I've noticed too is like if I'm just trying to recreate it, but like if I Kyle sets up a lot of projects like this where he'll have he'll have the like he'll have like a make shell which imports or like puts Cabal install in the environment, but he doesn't get like the packages like the Haskell packages through Nix. And whereas I've always done it the opposite. I'll always get the Haskell packages through Nix, and I'll see it work differently. Then you have if you just have Cabal in the environment, then it's just gonna go through and install all the scripts. Sorry, all the libraries, but it's it feels like there's a lot of like Cabal stuff that's made redundant by Nix. But what was also interesting is like, and I don't know if I get it, is like there's a lot of people in Haskell who like also just don't like Nix, or like don't like the idea of like Haskell being so closely tied to Nix. But like
I can understand. Do you? Because if I can kind of understand to one extent, just in like Nix is not only concerned with Haskell, so it will make design decisions that aren't necessarily entirely for Haskell. So I can understand people wanting an package manager for Haskell specifically that works specifically for Haskell.
yes,
But at the end of the day, if you've got all your packages on a system, all you want to be able to do is say, go grab me these packages and install them in this well, we would invariably want it in a shell, so
yes.
it's not in conflict with anything else. So I don't really understand what, apart from you just don't like Nix. Okay, that's fair enough, but I don't quite understand why that'd be an issue. And for me, I think, to be honest, I mean, maybe something I might look in after I've done a few projects I've been doing at the moment, which is just how do you do like versioning, figuring out which packages they are, and then just have something that effectively just feeds into Nix. So because my way I've got Cabal to Nix, so I basically get a Cabal file, I effectively feed that into Nix, and then it just Nix installs it.
Yeah.
But then I do use things like Cabal REPL if I'm just in the Nix shell, because I use something called direnv, which automatically puts you into the shell. So if I just go into my project, I don't have to run Nix shell or anything like that. It just automatically just puts me into it. So it's just, and it feels very much just like any other part. It doesn't change. So because I use ZSH, and if you just use Nix shell, or even if that's the flake one or the normal one, you it will put you normally into a bash shell. Whilst direnv will respect the fact that it's a ZSH, and I've got all my shortcuts in all my shells as well. But therefore, I have to use Cabal REPL to then get into the REPL. So if you did get rid of Cabal, you would lose some of those commands, and I suppose it would be a question of how do you launch a REPL without
Right.
Cabal as well as. So there are a few other things maybe beyond
Right.
that, but I still feel like that GHC doesn't GHC just come with the REPL anyway. I don't know.
Yeah, because there's like
I just wonder.
GHCI
Yeah,
has a
yeah.
REPL. I can import.
Well, I'm just wondering. I think the thing is, if you use Cabal REPL, it will automatically load all the packages in your Cabal file into that REPL, right?
Yeah.
So you don't have to go through and import all of them manually. So you know what I mean? It kind of loads them automatically, I think. But I don't know if it's a huge advantage. You know, you could probably do a setup script that gets around that.
Yeah.
But
I,
yeah, I don't know.
well,
It's
I
probably
think
not massive.
I think it's funny because
Sorry.
it's on. Sorry, I keep interrupting. That's my bad. But like yeah, it feels like there's like GHC, which like the GHC glue Cabal, and then like Nix on the other hand, which is like a better. It's really a better version of Cabal. But yeah, it's
Yeah.
not specialized to Haskell, um, and it's like there's like so little. I don't know, like so little that it does or whatever. Like I know, like even if I like look at other um, what is it, scrapers. Like where is this? Scrappy core. Do we have something here? Yeah, like our setup.hs, and it'll just be this. And I think that's what Cabal is doing. Um, can I even test this? I wonder. Oh, okay. Next shell. Let me just do this piece by piece. Oh, okay. Uh, I don't know why that's not working, but oh, okay, because it's old. Okay. Um, well, whatever. I guess I updated my system and I haven't run this in a while, but
Yeah.
yeah. I'm pretty sure. Like I think if you don't have this, it will fail. But I'm like also just like what even what does this do? Like default main. Right, distribution not simple. Yeah, like it's. I feel like it's like literally got to be just this, like default main helper, which I guess there's a fair bit that
But,
it does. Like it's.
yeah, it's got to pass the YAML file, doesn't it? Um,
Do you mean the Cabal file?
yeah, well, the Cabal file is basically just YAML, isn't it? I think
Pretty much, yeah.
um, so it must be passing that in some way. Yeah, I think the only thing I can think that it really does beyond maybe some of these kind of basics, because you can just write a Haskell file, right, and then just compile it with GHC.
Hmm.
So the only thing I can think Cabal really does is versioning, because that's the only thing, you know what I mean? Like, so I don't know. Maybe I need to look into what actually is Nix from what is Nix taking from the Cabal from Cabal to Nix,
Right.
and how's it turning it in? What does it turn it into? So what's it taking from the Cabal, and what's it turning it into?
Right.
Because then other things I think might be just be like, yeah, I don't know.
Yeah.
Yeah,
Yeah. No, it's interesting. Like, and that's something I'm trying to continuously like just learn as I go is like how to like what is the line that like ends for Cabal, and I was gonna say here. I mean, like yeah, like Haddock or whatever. I guess is like another thing. But again, you can Haddock just throughout Cabal. It feels like it's almost just like the like the glue, of like all these different
yeah.
things. I suppose. Um, and even yeah, like I guess like I don't know. I yeah, I don't know. I really don't know.
It's an interesting one, isn't it? But it's like it obviously does some of the installing stuff, and that's the kind of stuff you don't really need it to do anymore.
Right.
It would almost be like some of this other stuff. I think it is the glue, and it is useful. But I do feel like if you stripped out all the actual package managed stuff and just said, "Hey, we're just going to use Nix for that."
Right.
How much of this stuff is it? I mean, because if you just have it like a slimmed down version of Cabal, does that really get you much more than just using Cabal? Probably not. But it's one you do feel like it's just slightly overpowered for what you're really using it for.
Cabal is right, or yeah.
yeah, Cabal. Do you know what I mean? Like
Mhm.
it's just like you feel like it's just a bit, maybe a bit doing too much. But I don't know. Yeah, it might be just it might not be. It's something I need to dig into more, really figure out what Cabal is doing, and you know.
Mhm.
But
Yeah.
then you can't really force things into GHC because we're not doing that. But you do realize sometimes like could some of the stuff be inherited into GHC? But then that would probably then people would be like, well, then you're forcing everyone to use Nix and blah blah blah.
Yeah. And what is it? There's like another build system that they have, which is like I know
Stack,
what was that?
stack.
Oh, not stack. It's to build the actual like uh it's build the actual what do they call it? It's something particular. Hadrian. Yeah, Hadrian.
Oh, wow.
Yeah, I did I did one one Haskell or sorry, one GHC uh, PR and um, I learned about Hadrian. Um, but it's just I guess it's just like the I don't so this is probably just more of a it could just be a curiosity point on my part that's like led me astray, but I know like yeah, it's based on Shake, which is itself a Haskell library. And this is just like it's used to manage the build stages of GHC. Because if you go and actually build GHC, like it takes quite a while. And it's got a bootstrap. It's like GHC is built by GHC, so it's really important to like kind of have this build graph of GHC stage 0 allows you to build stage 1, gives you the pieces you need for stage 2, et cetera, so forth. Base is the library of base, all the core packages. Um, and yeah, then I guess that allows you to do integer stuff or integer versions of GHC. Yeah, but I don't know. I guess I'm curious, like, because like the controversy that I saw a while ago was just that like, why are they putting so much effort into Hadrian when Cabal exists? And I guess I'm almost
Mm.
wondering if like it just feels like Cabal is like I wouldn't be surprised if like Cabal like just like no longer exists in the future because like they just made Hadrian like you know like a simple version of Hadrian or something like that. Like it's because I believe Hadrian could build whatever. Like it feels like it's more powerful than Cabal if it can bootstrap. So then like I guess and maybe it makes sense to keep Cabal as something simpler. But I don't know. I'm very curious on the relationship between Hadrian versus Cabal.
Yeah, I think I hadn't even heard of Hadrian, but I mean, I think maybe it solves some of the problems. 'Cause, like a lot of people, a lot of times you use Stack on top of Cabal, wouldn't you? And I think Stack has now really become replaced with using Nix on top of Cabal. There was always those people who were just like, no, I just use Cabal or I use Cabal plus, Stack.
Yeah.
Um, and then I don't really hear many people talking about Stack. They just use Nix and
Yeah.
Cabal. I mean, you can use. I mean, one of the things Stack has that Cabal doesn't and Nix doesn't. I did think about this for a while, but I just felt, oh, chronic, this is another thing to put into a project. But it's Stack has templating, so you can template projects more easily. So if you want to create project templates,
Mm,
you could use Stack to template it. That would also build your Cabal file for you, and then you could use Nix to process the Cabal file outputted by that to then do the project, if that makes sense.
yeah.
But it feels like you have to use a lot of things on top of a lot of things on top of a lot of things to do maybe just one or two things. It's like, well, maybe just use a a standalone templater and maybe a standalone versioner.
Right.
But maybe Hadrian also does that. I don't know. I'll have to look
Yeah.
into it really,
Yeah. Cause I know it's
because
like
you don't need
go ahead.
because well, because Stack allows you to kind of build
Yeah.
things in more. I think actually Cabal does now as well, but like it was Stack originally was one of the things it did was it allowed you to build it not in shells but sandboxed builds
Hmm.
more.
Yeah.
But Nix does that for you. It's not something that, you know what I mean. A lot of these things just have a lot of things you just don't really use. You use them for one or two things.
Right. Well, I know with like okay like this kind of brings me to a point I was going to say, but I guess I just opted not to or something. But like I know through Stack you can enable Nix, and like so Nix can be used under the hood by Stack, and I'm almost like,
Ah,
like why doesn't what like would Cabal ever want to do that? Like because it's like Nix is the best at like the specific thing that it does. Like having like the idea of like a Nix store is just so smart. Like it's like a hashed store where you like you have very specific like pin builds that can be used by something which happens to be using the same exact package format or whatever. Like I just like, there's no better way to do like the core of Nix. I think Nix packages sucks, but like you know, or like nothing. It's not. I shouldn't say that. It's awesome. It could get better. Um, but like Nix at the core of it is like awesome. And even like I know there's like a push for like Haskell Nix, um, or like HNix that some people use, and I don't know. I just like I want to be as a like I'm really curious like what the future holds for like something like Hadrian. No one's really talked about like it replacing Cabal. I guess at least from what I can tell, Hadrian. Let me try actually. Haskell Reddit. Was that where I saw it? But yeah. Wait. I guess like could you? Oh, this was from 7 years ago. Jeez. Um, and it's interesting too because like this even kind of gets on another. Like, this is actually I believe Shake code. Um,
right.
which is pretty cool. I could even I even wonder about using Shake to build runghc BWrap, but because you also have like C code that you can use, and now there's like other like the foreign function interface. I'm sure that's going to continue to just evolve, right? Like between we have like C, we've had C for a while. There's JavaScript, which is now really great. WebAssembly as well. Um, and it's like I don't know. I feel like a build system like that. It almost just makes more sense, I guess. Um, I don't know. Um,
Yeah.
but yeah,
Yeah. I feel like yeah. I think it's the problem is if you've got people who don't want to use Nix, there's always going to be that kind of like, where does the build system, what does the build system need to do? You know what I mean?
yeah,
Um, but it feels like, yeah, if I think it'd be quite good if there was a project for like, let's build a new Haskell build system it's going to target Nix, um, but handles all the things that Nix can't handle. Yeah, just the things between gluing GHC to Nix,
right.
uh, with as minimal kind of thing. I must admit, because I'm doing a multi-project lab thing now, and this is not actually to do with that so much, but it is Hang because I know you don't really use it, but I use HLS, which is fine for kind of single projects. But I have
Yes.
to restart it all the time when I'm doing it on a multi Cabal file project.
Mm.
But to me, this feels like why is it so bad at this? Like if it's written in Haskell, which I think it is,
Right.
it should be really good at It should just manage. Do you know? I don't know why. I don't understand why it can't manage those really well. Because to me, that's just like STM. Sure, you just have different queues with different things and then pop them out. I don't know.
Yeah. Yeah.
Just should be able to just do. If any language should be good at running multiple projects at once inside of a program, it should be a Haskell project.
And you know what? Like, yeah, I'll echo that because like I'm just like, you know, like I'm amazed that like these really convoluted object oriented languages are able to like have like the ability to look up and take you directly to source or whatever. But yeah, like in Haskell with HLS, if you want to go like I think you can jump to source with your own project definitions, right? But you can't with like
Yeah, yeah.
external or
Yeah, no, it doesn't. But I don't. What I'm guessing that's because if you've installed the binary, it doesn't have the code there. I have also got like in my IDE Hoogle that you can just bring up in the IDE, but it doesn't give you all the information. So you really want it just sometimes it just gives you I don't know why it just doesn't seem to represent it very well. So I don't know. There is just this not that I think so. Yeah, again another I think probably more than if I looked at before I'd look at the actual build tools because the build tools work. They're just maybe a little bit kind of like you're using this and that. But I think the thing next I'd look at next would be like HLS because I just or making
yeah.
an alternative to HLS because I just feel like it should a Haskell language server should be able to run multiple projects
Yes.
and feedback errors to you. Get that done before all the because there's some really fancy stuff as well. Like and it's just like well get the basics working. I can just let me have multiple
Right.
cabal files
Yeah.
and report the errors where they're happening and let me jump to those errors really quickly and easily. That's the basic of what you want. And then yeah, going to source would be really good. But like if it should just be as simple though, almost like if you haven't got the surely you've well I'd maybe make it part of it is make sure you've got Hoogle installed, and the if you haven't got the source code, at least open the the documentation for that function. I don't know, yeah, or yeah, I feel like it should be a really solvable problem because even if you go to Hoogle online, you can jump to the code, can't you, from that? So uh, yeah, I don't know why it doesn't work for HLS.
Hmm.
Um, it feels like a really solvable problem, but I feel like it's one of those things where people have been more interested in the fancy get it to produce. You know what I mean?
Yes.
Like you can do things with it which you can't do in other words, which is like getting it to print out results inside of the text if you use this special notation and stuff. I'm like,
Right.
that's cool, but I'd rather it just work over multiple project files, to be honest.
Right.
um,
And I was like I was curious about this because like HLS well how old is HLS? Let me ask ChatGPT here. How old is Haskell language server? Um.
maybe it's not the modern thing to use, and I hadn't realised it isn't as old. Yeah,
Hmm.
2020.
Yeah, like that's like
Um,
insane. I literally started.
5 years old.
I started using Haskell in 2020. It was just kind of interesting. This actually like, and the reason I find that interesting is I'm like, why did I never start like I started not like without using HLS. And it was just like,
Same here. I mean, I remember when I first started writing Haskell, I would literally, because I hadn't heard of some of the other tools, I'd literally just compile it. I'll just have I'd have a terminal open to the place that'll be working, and I'll just type something, then compile, get an error,
yeah,
do a type it, and then I realized you could have that just running all the time with, I want to say GHC. I mean, I used to I mean, the main thing I used was GHCI when I
yeah,
first started. I just run things and things on that. But yeah, but then the one that you use for Obelisk
it would
kind
be
of style is what's it called? GHCID. That's the
yeah.
one. Yeah, yeah, whatever. Yeah,
I think it is.
that's it's yeah. And then when I realized that, I was like, oh, I don't have to keep saving and running myself. That's really nice. And
Yes.
then that's when HLS started coming about, like because there was other alternatives, but they were IDE specific. And if you like me wanted to use Vim or if you wanted to use Emacs,
Yes.
was a bit more limited. But there were even then like solutions to them. They just weren't particularly all that good. And then about, I think it was about 2, maybe 3 years ago, HLS actually got good enough to use. But I am finding now that when my personal projects are getting more complex, HLS doesn't it is struggling, in
Yeah.
my opinion. Maybe I'm doing something wrong. That's possible, but then again, I just don't think it should be that difficult to say run language server on this project, please. Like,
Right.
you know, read the Cabal files and figure yourself out. But that's is always easier to say than it is to do. But
Yeah.
um,
Yeah. Like I'll
yeah.
say too. Like I want to. Like I was trying to get more time to spend on like I wanted to kind of become like a GHC contributor at one point, and like honestly, just with like the state of Haskell language server, because like yeah, I still don't use it. Um, I want to integrate it into Jenga framework, um,
Mm,
but I'm having. Well, I just got to return to that. I think I found a solution. I forget where I got stuck on, but there was some challenge of sorts, and um, this is so crazy that I guess like 7 years is like when it's like the newest or whatever. But even I guess we're in 2026 now, so it's still 2019ish, 2018.
yeah.
Um, where's it going? But yeah, I think I'm gonna spend more time. Like if I am going to commit time to like the open source community, just I'll probably actually focus on the Haskell language server, because like it's clearly the biggest fall down of Haskell. you know.
Yeah, I think it doesn't work amazingly well, and or even if it maybe it does work amazingly well, but it doesn't seem to integrate very well with a lot of people's solutions. I'm not the only person I've heard whinge
Right.
about
No, totally.
Haskell, yeah,
And
language server.
and I'll say too. Actually, you could probably make use of this is from a guy I used to work with. Oh, it's not okay. Openstein. So he took Obelisk and made it something that uses HLS. And here's how he did it. I'm trying to remember what like the key detail is, but I think it was just like I don't know. I think yeah. I mean, it would probably have the same other challenges as I think I tested this too. I think there was like the same challenges that you described with like multi library.
Well, I
Yeah.
well, I because I did actually play around with trying to get Haskell language server to work with just Obelisk, and because I was using a flake to wrap around Obelisk anyway, and then when I what I found was I could get it to work with most stuff, but all the obelisk defined libraries, which weren't maybe necessary, it was really hard to get HLS to pick that up. So it would be like, I don't know where obelisk frontend has come from. I don't know where that
Yes.
library is. So trying to get it to read where certain libraries were from and then understand when you're importing them that they made sense. That was I just couldn't get that to work. So maybe he's done it this way,
I
but
think
everything I found was it didn't read everything. If you know what I mean, but I could be
yes.
wrong.
There was another thing I ran into when I was using this that I think it was something to do with well no it was actually Jenga specific, so I kind of that would probably be something I need to fix or whatever, but I think those packages worked properly with this setup.
Okay.
I would love to hear how your experience goes with this. Um, the one challenge being this was maybe this is even where the challenge came from is that I am on currently GHC 810, and so is Jenga at the moment. Um, but and Obelisk there because of then that's why Jenga's on 810. Um, but there are even like just some up and coming branches of Obelisk that do use 910. Um,
Right.
so yeah.
Maybe that solves some of the problems. Yeah.
Oh yeah.
Well, I suppose. Oh, well, I mean, maybe that's part. Well, I know because hasn't Reflex been is moved now fully into the kind of normal Haskell libraries.
Yes.
Um, maybe there's an element of that making it a bit easier. I don't know.
I know too. Like
Mm.
it's interesting because like Obsidian too. I gotta say, like I really gotta hand it to them. Like I knew they were like pretty what's the word I'm looking for? Pretty innovative and like ahead of their time, but like they were really like ahead of their time. Like like Reflex platform like a lot of the stuff they did. I'll go to our version because I know it better, but our fork of it. Um, but like yeah, I know there's a big push. Or actually, wait, no, sorry, I would need to go to um, Reflex FRP. But yeah, I know there's a big push to use Haskell Nix. This branch has quite a fair bit of work on it. Or was it GHC 910? There was I'm trying to remember what there's a particular branch. I could probably find it by just looking at the history. Yeah, new backend WASM, um, and or maybe even it's in develop. But yeah, no, they're starting to use Haskell.nix. Are you familiar with Haskell.nix?
Um, I've not. I think I looked at it for a bit, but then when I tried to use it, I think I ended up getting some weirdness,
Yeah, that's fair.
um, and I haven't gone back to it. But it was quite a long time ago that I tried it. I think, but I
It's
think I might have tried it when I first started using Nix actually, which was probably a couple
yes,
years ago now.
that makes
Yeah.
sense. Where is it? Like and it's pretty cool. I mean, um, where can I find this on GitHub? I'm trying to find Haskell.nix. Yeah, and I mean IOHK is a monster. Well, like monsterly large. They're not monsters. They're awesome people. I'm sure. Um, but I thought they had an example. Oh, okay. It took me right back here. But yeah, like it seems like pretty straightforward-ish or whatever. I know you can also like build um for like the Windows, which is pretty cool. And you know what? That's really the real problem with Nix is that it doesn't work on Windows yet. Um, but that yeah
It doesn't really affect me. It doesn't affect me. I
yeah
use NixOS mainly, so
right
that's not a problem. But yeah, probably for its mass adoption, if you can get Nix working on Windows,
yeah.
then that will get people using it more.
hmm
Um,
I know there's like active work to do it, but it's probably still some time. So
mm.
what was it like? Yeah, they have a bunch of. So I mean, I don't know. It's I feel like it honestly seems like too like if you look at like Nix as a whole, like it feels like the most people are like from Haskell, which is just like interesting to think about. Um, or like yeah, maybe not all definitely not all people from Haskell, but like even I know like one guy who was on the board before was like John Erickson, who like I worked with at Obsidian, and like he's obviously big into Haskell, like has worked on GHC. Like there's a lot of people from GHC, even like group chats that I'll see that are also active in like the Nix group chats. So.
yeah, I think it's a very similar ethos, isn't it, to Haskell,
hmm
being lazy and functional.
Yeah.
I don't know how you'd get types to work with Nix, but part of me does feel like some of the issues that I find with Nix might go away if there was a kind of slightly less dynamic typing system.
Oh yeah.
Um,
I, I,
but I don't know. That might become a bit of an impossibility to wrangle. I don't know.
I will say I know that like Obsidian was like at least when I worked there was like actively like thinking about how to to do that or whatever. Like that was one of their biggest frustrations with Nix was like that it just sucked for types, and they actually had like a
Yeah.
lot of like builders. Like if you go to Obelisk and like look at the lib for command, where is it? Yeah, they have Nix Obelisk command Nix, and it's just a bunch of like how to build a Nix expression.
Right. Yeah.
So
I mean, that is it kind of becomes a circular thing using Haskell to build the Nix to build the Haskell.
yeah,
But yeah, at some point you just have to get to the brass tacks.
yeah,
But yeah, it does feel, yeah, it'd be nice if you could just define things a little bit more concretely
right,
in Nix, and we'll just see how yours how it breaks down, because a lot of Nix does feel like you just have to remember that's how you do it in Nix.
right.
Um,
It
Whereas Haskell, you should always be able to work backwards from either the documentation or just the type, the code that you're using, the compiler,
right. It
what you need to be doing.
I know a big challenge too with like using Haskell in a Nix setting is that like the imports need to be lazy, right? So like Haskell, Haskell's lazy, but like these imports are actually strict, right? So no matter what, um, like when it's reading the code, it's going to try and import these symbols, um, whereas Nix, if you did that with Nix, it would be like an explosion.
Massive, yeah,
Yeah, yeah.
yeah.
So
Well, there's plenty of things we can do
yeah.
inside of the community. We just need to do it.
Exactly. Yeah. So, yeah, no, like and a lot of cool shit. So, um,
Yeah.
but yeah, no. I'm gonna say, I'm just looking at Zen's question here. Present my question with an example, but I'm still working on it. I should be able to build.
I think I am gonna have to bounce now, though.
Yep, I should
But
probably
great.
too. So,
Catch you next week, and see you in a bit, Sergio. In a bit. Bye.
See you. Have a nice weekend.
nice. See you next week, Sergio. Great to see you guys. So, that was great.
Bye.